Today I'm going to be talking about the combination of conformity and interoperability. Definitely related to each other, so I'm going to do a little back and forth through the presentation to understand where they both hopefully converge so that we can get toward a better standard and accurate non-time charging. As you heard this morning, electric charging isn't as easy as pumping a tank of gas. So when you look at stopping at a gas station, I'm sure you've all pulled into a gas station over your driving career and seen a bag over the pump out of order, right? You simply pull up to the next pump, plug in the nozzle, and you pump your fuel. At 25 to 40% failure rates of charging, it's pretty rough on a customer. Your early adopters tend to be more okay with inconvenience than your average folk, right? Once you get to the adopters who are looking for an appliance, a toaster that works every time they pull in, not being able to charge is a headache and a hassle. So when you get the red instead of the green, you definitely want to be able to get away from that. Are there mechanical failures or physical failures at charge stations? Certainly there are. One of the interesting ones I saw that a cable was cut at the top and they were stealing the copper from the cables, right? They cut every one in an entire charge installation. Obviously, your customer is going to know if the plug is missing, he can't charge. But it gets a lot more complex when a customer plugs in, waits the minute or 2 minutes for the connection, and nothing happens, right? Gets a red button. So the idea is to work toward two things. We're going to look toward getting compliance or conformity, and typically this is done via the standards. You certainly see the DIN, ISO spec, the IEC specs. Most certainly here in the US, we have our SAE specs. And the idea is for everyone to work toward the same specification so that everyone works and plays well together. The reality of that is, particularly with complexity, there's always room for interpretation, right? That's why guys like Dirk and others work on making those specifications very well written, very well explained, so there is less room for that interpretation, right? And ideally, at some point, no interpretation, right? Everyone works the same way. When you're looking at interoperability, the idea here is how do we test that, right? What we're doing today, you'll see an awful lot of our OEMs. They put together fleets. They have their test fleets that are available, their management vehicles. They send their employees out with vehicles to various charge stations to plug in, make sure everything works at the vehicle side, and that charge station in particular is functional. When you look at what we're doing in the industry level, you're certainly going to be seeing things like the char-in testables. Plenty of these events are planned across the globe, right? It's not just here in the US, Asia, Europe. The standards obviously differ slightly or significantly, and everyone has to do that. What do you run into there? The problem with infrastructure and being able to put a bunch of chargers in and the costs associated with shipping vehicles to a certain point to do that. So the idea is to get away from doing ad hoc single point testing and get to a point where, from a conformity side, you can run test cases, both good and bad, and you can have reproducible, scalable, and automatic testing, right? The idea for conformity is we want to make sure we can run those tests over and over and that those tests pass each and every time. On the growth side, because we're engineers, we can't stop with good enough. We always have to add more, or we need additional functionality. That circle gets bigger, right? So after the 15118-4 spec, right, you're stepping out to 15118-20, and there is plenty of additional work to be done, not only there, but with megawatt charging systems. So the work doesn't end once the spec is well recognized by everyone, right? The specs grow. On the interoperability side, when you're testing a vehicle versus a charge station, you're plugging them in, you're doing a single point test, and it's testing for the good cases, right? So you're looking, expecting the case to work after plugging in, and if it doesn't, well, then there's more investigation that needs done. That also grows and gets more complex as you add those standards, all right? That circle's growing with us too. The difficulty, as I mentioned, is the cost and overhead associated with the testables. It's not easy to put together going into the double digits of charge stations at a single location. We're lucky enough to have Lincoln Electric host an event. Since they know power, that was definitely easier for them to do than some other locations we've been at. But as a test engineer my whole career, do I get tired of traveling? Sure. Ask any test engineer who's been at it for a while. You get tired of traveling with the vehicles to the test events. So the idea here is to kind of bring together conformity testing and interoperability testing to do as much as you can over the course of a test at your facility, right? The idea is you can put these tests together, and when you run the conformance tests, be pretty sure the interoperability, or ideally 100% sure that interoperability is going to work too. When you look at the design V, how can we help you do that? On the design V at the bottom end, you're looking at basically the software side. So you're looking at software in the loop. As you walk up the right hand of the design V, you're starting to get into your ECU side and then eventually your vehicle side content. We want to be able to help you with all those with all the standards that you see below. The idea is to build a system that allows you to do so, and really the heart and core of that system is Canoe with smart charging option. Additional to that, to get the tests built and run, we add VTest Studio. And then as you see, everything on the right-hand side to include the conformance test packages can be used from the software in the loop all the way up to the real vehicle and charge station implementation side. So you'll note the other green slices. SIL-Kit is a way to do that. vVirtual Target is our software for testing vector internal software. When you move up to ECU level testing, some of the equipment that you see outside is doing that simulation of the communications, obviously without handling real power. And then once you get up to the top of the line vehicle or charge station, again outside you'll see a VT system rack that can act as either a vehicle or a charge station. So it's important to catch those errors early, right? At the software in the loop side, continuous integration, continuous test. The idea is on every software release to run those additional tests to make sure that you catch issues before they actually spool and propagate into either your ECU level or even worse, into your vehicle level. The earlier you catch those issues, cheaper it is to fix them, the better you can deploy to your customer. So when we look at testing in the field, once you get beyond just the SIL, HIL, and HIL implementations, we're looking at actually testing or listening into conversations. And the idea here is to use that same underlying software, which is Canoe, with an additional piece of hardware called the VH5110 to listen into a conversation. So what we're seeing in this instance is a conversation between a vehicle and a charge station. And what you'll note is the red boxes. So we're in pre-charge response. So the pre-charge request was 400 volts. The charger responded with 0 volts, yet you'll see the very next red box in the middle was turning the charge on, right? Shouldn't happen until your charge station matches voltage with your vehicle. So in this case, what we allow you to do is use the software to actually take bench issues back to test them against the other side. So what we're doing here is taking that particular issue into VTest Studio, and the conformance package and looking for that particular location where the issue occurs so that we can insert that very same fault that we saw in the real world. What happens is VTest Studio builds those test units. Those test units are loaded into Canoe and then executed. So when we look at what a test unit is, it's basically a three-step process. The top step is preparation, the gray box, and that's where basically you're setting everything as necessary for the particular test. The middle portion is actually the main portion of the test, and this is where the test actually executes and verifies or checks the content for the specification at that particular point. And then finally, you run a completion section where you put everything back to safe and normal conditions. So in the case we saw before, what we want to do is take that error that we saw using a listener and actually put it in and run tests with that particular fault. So going to do a little software for you. I bet none of you thought you were going to see software. I know I didn't when I saw the presentation. What happens here is we're checking if the target voltage is reached, and if it's not, we comment it out, sending the correct message, and we put in the incorrect message we saw in the listener here. So basically, taking the compliance test and modifying it to see an actual fault so that we can verify how the vehicle reacts to that. In addition, talked about the growth of standards. So Dirk obviously told you a lot about Dash 20, the bidirectional power transfer. Yep, these continue to need to be added. So testing continues to be added. There's definitely some differences with Dash 20 versus the earlier spec, the Dash 4 side. So you're seeing differences in the authorization side, where the authorization occurs, so a little bit of change in order, and you can see those on the left-hand side. In addition, Dirk also talked about the change in physical layer structure. So when we look, you'll see the 10-base T1S that Dirk mentioned. The 10-base T1S is basically, for those of you who aren't in a lot of networking, it's taking the Ethernet side and instead of making it point-to-point, making it much more like a CAN network with nodes. So that's another major change. Finally, mentioned you do need real hardware to run some of these tests. The VCTS system is outside. If you'd like to talk about it more, I'll certainly be out there in a few moments. The idea is to give you a tester that can operate as either an EV or an EVSE. And they can certainly do so. So finally, conclusion, getting us caught up here on time. The idea is to assure that we can run conformance tests that also verify a lot of the interoperability. So we want to make sure to give you a framework that if you do see actual errors, you can run tests and modify the tests. Note that we do give you a warning when you use the conformance test. If you make changes, we can't assure that it's still verifying the actual specs, but that's okay. You can do your own separate tests in another directory. So finally, the importance of conformance and interoperability, best addressed at the lowest level. So if you can operate at a sill level, excellent. If you have to operate as you walk up to hill or actual vehicle, and real-world implementation checking, Vector's always here to help. With that, take a couple questions.